In the previous class, we have seen that there are two methods to collect data for making inferences about population. One is sample, the other one is experimental designs or experimentation. So first we consider what are the various methods of sampling to collect data. And as we have seen, there are various methods of probability sampling to collect data, and data collection used by probability sampling is the most widely used as it enables us for statistical inferences, a point which we will discuss later. Now let us see what are the various types of probability sampling used for collecting sample data. The most widely used is simple random sampling. Simple random sampling. It is a sampling procedure in which each unit has an equally likely chance of being observed. It is a sampling procedure in which each element of the universe has, or each unit of this universe has, population has an equal chance of being selected. And a simple random sample is a sample obtained by the simple random sampling procedure. Now there are two types of simple random sampling. One is simple random sampling with the replacement. With the replacement means an item is selected. Before selecting the next item, it is replaced. So there is a possibility that the same item will be selected again and again. A second one is simple random sampling without replacement. And in this case, a member will be selected only once. A unit will be selected only once. And in inferential statistics, which we consider, it is assumed that we are using simple random sampling without replacements. Without replacements. Now the question is how to obtain a simple random sample. Now, if the population is very large, obtaining samples by simple random procedure by writing the numbers of the samples in a piece of paper is very difficult. So for simple random sampling, we use the table of random numbers, or we use random number generators. Random number generators. And today, with the availability of high-speed softwares, statistical softwares, we use random number generators. For example, if the population consists of 1,000 members, and if you want to take 100, these 100 members are selected by using a random number generator. That we will see using the software. That is the most widely used sampling procedure. But this is not the only sampling procedure available. And remember that simple random sampling procedure, even though it is the most widely used and readily understandable method of drawing samples, it has two drawbacks. One is it may fail to provide sufficient coverage about subpopulations. About subpopulation. If you have to get information about various subpopulations like men and women and many other community, caste, etc., simple random sample may not give sufficient information about these subpopulations. The second is, it is not a practical method. If the population is widely scattered geographically, if the population is widely scattered geographically, then simple random sampling procedure may not be practical. So we use other probability sampling methods other than simple random sampling. But when we use the other methods for inferential procedures, we have to modify the inferential procedures that we will discuss later. Now let us see what are the other methods of probability sampling other than simple random sampling. One is systematic random sampling. Systematic random sampling. Systematic random sampling. Now, in the systematic random sampling, we divide the population size by sample size. If the population size is n, sample size is smaller than n, then we divide the population size by sample size and round the results to a whole number, say m. If we obtain a fractional number m, we will consider this with an example. Then we use the random number table to obtain a number k between 1 and m. Between 1 and m. Then we select the numbers as first number is k, second is k plus m, third is k plus 2m, etc. Let us see an example. Suppose that we require a sample equal to 15 from a population equal to, say for example, 7 to 8. Then 7 to 8 by 15 is equal to 48. 48 is m. Then obtain a number between 1 and 48. Let this number is 22. So the first number is, sample is 22. The second is 22 plus 48 equal to 70. The third is 22 plus 2 into 48 equal to 118. Then 3m, etc. until 15 samples are collected. So we divide the population into m groups, randomly select a number k, then samples are selected as k, k plus m, k plus 2m, etc. This is systematic random sampling. Systematic random sampling. The third one is cluster sampling. Cluster sampling. Cluster sampling. Now in the cluster sample, this cluster sampling is used when the population is widely scattered geographically. Widely scattered geographically. Cluster sampling is used when the population is scattered geographically. The steps are: we divide the population into groups, or what is known as clusters. Population into groups or clusters. Then obtain simple random sampling. Obtain simple random sample from clusters. Obtain simple random sample of clusters. Use the number of clusters so obtained as samples. Use the number of clusters so obtained as samples. Now let me consider an example. Suppose that n is equal to 300. That is the population. Divide this into equal sizes of 20 each. 20 each. And we want a sample equal to 60. N is the population. Divide it into 20 clusters. So 300 by 20, a total of how much? 15 clusters. Sorry, 15 clusters. So we want n is equal to 60. Now, number the members of the clusters as 1 to 20, 21 to 40, 41 to 60, etc. So we have a total of 20 clusters, sorry, 15 clusters, and from 15 clusters, using random number tables, select 3. Let it be 3, 4 and 10. 3, 4 and 10. Then the samples are 41, 60, then 3, 4, 10. Then the numbers, clusters, first cluster is 3, second one is 4, first cluster is 3, second is 4, third cluster is 10. Total 300. Number of clusters 15. In each cluster we have 20 observations. So in the first cluster, third cluster we have 41 to 60, fourth cluster 61 to 80, 10th 181 to 200. Sorry, 10th cluster is 101 to 120 like this. We take 3 clusters, the third cluster, fourth cluster and 10th cluster. Fourth cluster is 4160, first is 20, 2140, third cluster is 4160, sorry, fourth cluster is 6180, third cluster is 4160, fourth one is 6180 and 10th cluster is 181 200. So we have samples 41 to 60, 61 to 80, 181 to 200. So the procedure is we divide the entire population into clusters. Clusters, as an example, 15 clusters here. Population is 300. Each cluster is the population is divided into 15 clusters of equal size. Then we want say 60 observations. Then we select 3 clusters because in each cluster there are 20 observations. And these 3 clusters obtained are 3, 4 and 10. And the sample observations 41 to 60, 61 to 80, 181 to 200. Now, to be a reliable sampling procedure, each cluster should mirror the entire population. And this may not happen always. There are situations in which the clusters will not represent the population. Population in each cluster may be more homogeneous than the entire population. Such a possibility is there. But this is a method if the population is scattered widely geographically. That is cluster sampling. Remember this, once the population is divided into clusters, we take samples from the clusters, or we take clusters as the samples, and the entire cluster is included in the sample. Entire members of each cluster is included in the sample. That is cluster sampling. The next one is stratified sampling. Stratified sampling. A fourth one is stratified. This is a method of sampling in which the population is first divided into subpopulations known as strata, and sampling is done from each stratum. Sampling is done from each stratum. Population is divided into subpopulations known as strata, and sampling is done from each stratum. Now, ideally, members of each stratum should be homogeneous relative to the characteristics under consideration. For example, if you study the income distribution of the population, you can divide the population into various stratum as high income, middle income, low income, so that sample or population in the low income, middle income and high income will be homogeneous. Now, strata are often sampled in proportion to their size. That is, samples are taken from each strata in accordance with this size, known as proportional allocation. So the steps are, first we divide the population into various strata. Second is, from each strata, obtain the samples using simple random sampling using the formula total sample size into size of stratum divided by population size, and use the numbers so obtained. As an example, suppose that n is equal to 2000 and you want a sample equal to 10. And suppose that this is divided into 4 stratums having 400, 600, 800, 200. Population in each stratum 400, 600, 800, 200. Then from the first 10 into 400 by 2000 to second 10 into 600 by 2000 is equal to 3. From the third it will be 4. From the fifth it will be 1. So from the first strata we take 2 samples. From the second 3 samples. Third 4, 1 using simple random sampling. And you will get a total of 10. Here it is stratified sampling is different from cluster sampling. Cluster sampling is used if the population is geographically scattered. Geographically, for example, if you, in India we have so many panchayats. If you want the panchayat level data, local level data, this provided that the population is homogeneous, cluster sampling is used. Stratified means population has distinct characteristics. So we classify the population on the basis of these characteristics. And in each strata, population will have same homogeneous characteristics. And from each strata, using simple random sampling, we select the sample size. Here, clusters are randomly selected and every member from the cluster is taken. Here, stratification is done and from each strata, samples are taken. That is the difference. These are the most commonly used type of sampling. In addition, there is also multi-stage sampling and other procedures are available. These procedures will be available in many textbooks. So these are the sampling techniques which we consider. Simple random sampling, systematic, cluster and stratified.